Whether it's your phone, your laptop, even your car, basically every piece of tech you touch has this secret ingredient. It's this hidden layer of software that makes everything actually work. We don't even think about it, right? But take it away, and our gadgets are just expensive paperweights. What is it? We're talking about the operating system.
So to really get what an OS does for us, let's do a little thought experiment. Let's just imagine for a second what a world without one would look like. And yeah, trust me, it's not pretty.
I mean, think about it. You see an icon on your screen, you click on it, and boom, it just opens. It feels so simple, right? It's almost like magic. But what if it wasn't magic at all? Because without an OS, you'd have to be the magician. Yeah, you. So, you want to open a program? Get ready to write some code. You'd literally have to tell the computer's hardware, all right, listen up. Go find this specific program on the hard drive, then take it and load it into the main memory. For every single thing.
Just think about that for a sec. Every single time you type a letter, you'd have to tell the computer how to draw that letter on the screen. Every time you save a file, you'd have to manually figure out where on the hard disk to put it. Can you imagine how unbelievably tedious that would be? Honestly, most of us would probably just give up. Computers would be totally useless.
Okay, so clearly that whole scenario is just not going to work. It's not sustainable. We needed some kind of invisible manager, something to handle all that crazy complexity for us. And that's exactly where the operating system comes in. It's the solution.
When you boil it all down, that's what an OS is. It's like the ultimate translator and project manager all rolled into one. You tell it what you want in plain English, or, with a simple mouse click, and it goes off and has all the super technical, complicated conversations with the actual computer hardware for you.
So if you look at how a computer system is built, it's all about layers. You, the user, at the top, then the apps you use, and way down at the bottom is the physical hardware. The OS, it sits right smack in the middle. It's the crucial bridge that connects everything, letting your apps talk to the hardware without either of them needing to know the nitty-gritty details of how the other one works.
And here's the thing, you already know these guys. You use them every single day. Windows, macOS, Linux. On your phone, you've got Android or iOS. They all look and feel a bit different, but underneath it all, they're doing the exact same essential job.
Okay, so how does this whole thing actually work? Like, what happens in that split second? Let's do it. Let's follow the journey of one single mouse click and see the OS work its magic.
So you click your mouse. The first thing that happens is that the mouse hardware doesn't just, sit there and wait politely in line. No way. It sends out this urgent, high-priority signal straight to the computer's brain, the CPU. And this signal has a name. It's called an interrupt.
The best way to think about an interrupt is like this. Imagine you're deep in a really good book, totally focused, and then, suddenly, your doorbell rings. What do? You stop what you're doing, you get up, and you go answer the door. That doorbell is an interrupt. It's telling the CPU, hey, drop everything, something important just happened, and you need to deal with it right now.
And the CPU's response is just incredibly quick and efficient. It instantly pauses whatever it was doing, jumps over to a special little program designed just to handle that click, does what it needs to do, and then jumps right back to its original task like nothing ever happened. It doesn't miss a beat. And who's the choreographer for this entire lightning-fast dance? You guessed it, the operating system.
All right, so to handle that click and everything else you do, the OS has to be a master at managing another really critical resource, memory. And honestly, the best way I've ever heard to explain computer memory is to think of it like a library.
See, your computer really has two different kinds of memory. There's what we call secondary storage. That's your hard drive or SSD. It's huge and it's permanent. Then there's main memory, which you probably know as RAM. It's much smaller, it's temporary, but oh man, is it fast.
So let's go back to our library. Your hard drive? That's the giant bookshelf that lines the walls. It can hold thousands and thousands of books. Those are all your apps, your photos, your documents, everything. And it holds onto them forever, even when you turn the lights out. Power off the computer? It's massive. But walking over, finding the right book, and bringing it back, that takes a little time.
Now, RAM. RAM is your work desk, right in the middle of the room. It's way smaller than the bookshelf, right? And if you leave for the night and turn off the lights, the desk gets cleared off completely. But any book you're actually reading is sitting right there on the desk, open and ready for you to access in an instant. So when you open an app, What's really happening is the OS is grabbing that book from the bookshelf and putting it on your desk so you can work with it quickly.
And this simple analogy, it perfectly explains why having more RAM makes your computer feel faster. A bigger desk means you can have more books open at the same time, more apps, more browser tabs, you name it, without having to get up and go all the way back to that slower bookshelf. And the OS is the librarian, the one who manages this whole workspace, deciding what goes on the desk and when.
Okay, so when you put all of this together, managing the clicks, juggling the memory, all of it, the entire job of an operating system really boils down to just two main goals. Two simple but incredibly powerful goals.
Goal number 1, convenience. Pure and simple. The OS is there to hide all that insane, mind-numbing complexity we imagined earlier and just give us a simple, beautiful, intuitive interface to click on. Goal number 2, efficiency. It's a master resource manager. Its job is to juggle the CPU's attention, the memory, the storage, everything, just to make sure that the hardware is being used in the absolute best, most efficient way possible.
I mean, think about it. From deciding which program gets the CPU's attention next, to making sure your files are saved without getting corrupted, to handling your Wi-Fi connection, the OS is this silent, tireless administrator working in the background, taking care of millions of little details so you don't have to. It's what makes everything we do on our computers possible.
So the next time you click an icon, just for a second, think about that invisible dance happening behind the screen. This incredible ballet of interrupts, memory management, and resource scheduling all happening in a fraction of a blink. Your OS makes billions of these decisions every second, and it gets them right almost every single time. Which leaves us with a pretty wild thought to end on. What if it got one wrong?